Okay, I think all systems are operational. Coffee is operational. And we'll continue with the backtracking problem. Here, did you notice last time? Back trouble, this is not going to work. Also, we are doing a different approach. I thought about it all the time since the last video. And we will do something like a backup. First we do a backup. That's the first thing. Resize the browser. And make a copy of, how long is it? 355. Our general logic engine. Backup before backtracking. Yep. Does it transpile? It does. So I call it a path. No, it should be a class, I think. We just record the steps we took in the program, and that enables our backtracking. Steps. And we have something called valid, which means can we still backtrack? Can we still backtrace this path? Quick reminder, this is the program here, and we want to backtrack this statement, for example. Here we chose a random x, and we want to backtrack to here and choose another x. That's what I'm trying to add to this logic engine. So we just pass around this path object. Path. And here we start with an empty path, I would say. How many calls do we have? We have multiple calls. That's okay. So now we have this path object. Path contains the previously executed steps with an option to backtrack. We don't have this option yet, but first we construct the path. Okay, step by step. This should be just the same path. It just goes over a list of commands. Next up, we have an if. We will not backtrack the condition for now. It's still the same thing. We don't record the condition, it's not backtrackable. We have a for. For is handled differently anyways. It's added as a new logic rule to the top level. We'll do that later. While statement, that should be easy. Yes, here. And we do want, I think, we want to keep the path here. Yeah. Our program contains a while, so we would need that. We need to add it to this variable, procedures to run. not a problem. It's just a procedure and a path. Done. Procedures to run. This should clearly have a constructor without a path. There. Procedure to run. Yeah, this should make a new path. There. Yeah. Now we can pass on the path here. Okay, we adapted this. That's okay. Oh yeah, but some more options here. Oh yes, we need to add to the path, of course. Let's quickly check if we have changed all the references. We have not defined a step class. Step. And here are the functions we want. We want this undo basically. We want to say do something else, and we want to say just undo the whole statement, roll back everything. These are two useful things. This first one we need first. What does it return though? That's not entirely clear to me yet. Maybe it's a flag. I believe it's the usual return type that native predicates have also. If I tell this statement here, do something else, what happens? It will look for another x. So it will return another mapping for x, if it found one. Or it will say false, there is no mapping. You can also just say true, it say I worked, but I don't return anything. And still I did an alternative thing here. So I believe, how about we make an alias for this? In JavaX we can make aliases. It's like pre-processing in C++, just not that nasty, I guess. I don't know. Native predicate return type bool. Yes. No. Yes. This is an ugly name, but who cares? Who cares? Let's check the stream. That's good. Yeah, need a better name here, for sure. I like these rewriting things. If I had object here everywhere, that was confusing. Now I can use it as speaking name, at least on the JavaX level. In Java, it's going to be erased to object. Okay, this comes later. And yeah, perform one backtracking step. Okay. Let's transpile. Transpilation music. No music. Oh, I came up with a smart idea to find the errors in the source here. Remember, this transpiles to a lot of Java code, right? And the Java code, the compiler reports errors, obviously, in the Java code, because the Java compiler has no idea about JavaX. So I get this here, I get a line number, but line number is in the transpilation code. And I thought, how can I map it back to the original code? If it's possible, it's usually not possible. You can usually tell where something ends up. Sometimes things get mixed in the transpilation. But yeah. Oh. Nice. Welcome to Greece. So now I'm confused. Audiences confuse me. I was saying I want to track the Java code to JavaX for the errors. And I could just put line numbers here, right? In the comments. Everywhere I put a line number with a pointer to the original code. And then when I get this error message, I get this line number here. And I can highlight the error in the editor. And I can even compile in the background. I can just type here and get an instant or almost instant error highlight, like they have in IDEs, because this is not completely an IDE yet. Okay, enough rambling about the future. What is the problem? Yes, this is of course abstract. This is an abstract class. Boom, one problem fixed. Step list proc, what am I doing? Huh? The context of the whole thing? This algorithm here. This is an algorithm in English. It maps questions to answers randomly. And we make backtracking. I want to backtrack this statement and this one and this one, like we do in Prolog. Do we have an output of the what? Yeah, something like this. Mapped question blah to answer blah. What is the time good? So this is a wrong mapping. And I have too many windows, I'm sorry. Here, these are the answers, these are the questions, and of course one mapping is right, one is wrong. But yeah, here, the code just goes randomly through it, and the logic engine should execute all the variations. So we need backtracking, and I thought about that yesterday all the time. And I hope I'm getting it done today. So, yeah. Okay, let's try to find the rest of the bugs. I try to put the program that we're making on the screen all the time, but there's limited space. on the screen. Abstract. It's obvious it's an abstract method. Compilers are so stupid. New procedure to run. Yeah. Okay. Okay. Yeah, I should really try to put the main program somewhere on the screen, right? Funny algorithm. Here, or no space anywhere. Here, maybe this. Yeah, no, it's not really. Whatever. Oh, it transpired, right? It did. So now we have these path objects, but we don't put any steps in them. This is what we'll do here. Applying var mapping. Have alternative. If the native predicate returns alternatives, we record it here. Path, add, new step. Alternative. This is my 10th logic engine or more, a lot more, I guess. I've been experimenting so much, coming from Prolog somewhere, adding English syntax. It's like Prolog, but a lot more flexible. I wanted to keep it in the chat so people can read it later. I don't know. The alternative. What is with alternative? Where is with alternative? Here, the native predicate returns a function. Yeah. This is the function we get. And we just call it, I guess. Maybe that's all it was. It doesn't work. I've heard the suggestion so many times. The engine is nowhere smart enough to understand random text. Maybe simple Wikipedia, but even simple Wikipedia is way too hard. This engine knows nothing. It's just an engine and you have to put in logic rules. You have to make these rules yourself. You can't train it with anything. It's not a neural network. It's basically programming. We make programs, but our programs will be so much simpler to make that it's almost like speaking English. And we have meta programs that help us program and so on and so on. So it's like classic programming. It's not trained really. It's just a different approach. Okay, we have all these steps. Let's go to the main program. Reload. It's really different from this neural network stuff. They take 1 gigabyte of data and train it forever, and it does something. And does it good or not so good? Like this GPT-2 thing that can complete whole essays. But after it's trained, you cannot tweak it anymore. If it generates garbage, it generates garbage. You can't do anything. Training is done. So I'm not very happy with neural networks. I can't inspect them, and I don't have the hardware to do this mega training. So I make small bots with no training. I really make programming easier. If you can make programming a lot easier, everything gets easier. As I said, my approach is to make languages that are almost like English. So what if programming gets a lot easier with this approach? And we can just program some AI. Okay. Here we define the native predicates. And then we just say bot run, and it will run the procedure. And I want to know when the procedure ends. On procedure ended. Yeah, we want to see the path. Okay. Map certain words to certain functions. We're doing that. We're mapping sentences. This is how it works. You have the English sentence here and a bit of Java here. So from there on you can use this sentence instead of this Java code. That's what the engine does. And here the same thing with a variable. If this all matches, then this calculates some x, and the x is used afterwards. So here we mix Java and English. And the engine does the rest. Run procedure. Procedure ended. It's certainly not easy to make English work as a programming language or any other natural language. It's certainly not trivial. That's why I'm researching for 5 years. I've been on procedure ended. Okay, we have callback, so we use the callback. On procedure ended. What does it get? Follows count, follows a procedure ended. I have something like this, standard toString. Give me some string representation. Advanced spelling makes Java code. You have whatever. This is Java Xcode, which is usually short, and Java code has 6,000 lines. And if you click here, after the imports, you get the original main program, just in Java. This is our normal Java, with all the long names and everything. And in Java X it's already short, S for string and so on. And it drags in all the functions it needs. It usually makes a program that uses no libraries. This uses just the standard library, but many programs use no libraries. They just have 6,000 lines of code, 33K in source code. They use nothing else. Every program is independent. That's really important. I don't want to depend on libraries so much. Libraries are a pain. Versioning libraries, it's horrible. If I can make small programs that are self-contained, the big programs have like 100K of source code, compressed source code. Those are big programs. 200K is really, really a lot. So it's not so big. Procedure ended. A procedure ended, and it recorded some steps. That's pretty good. These steps have anonymous names. Okay, yeah, this is working. It has run through this procedure, and it has a number of steps. How many steps do we have? 1, 2, 3, 5, 6. For whatever reason, it's 6 steps. So we want to print the steps so we can backtrack them. Here, new step. Yeah, this anonymous function that looks like crap, of course, but we can make it look better. What is it about, essay? What are you writing about? Thanks for visiting. Thanks a lot. Literature. School, right? So many weird things one has to do in school. I remember that. It was better in university because it was all related to what I wanted to learn. It was all related to computers or math or psychology. I did a bit of psychology in university. That was really weird, actually. Computing was okay in university, math was really okay. Psychology was weird stuff, I have to say. Weird studies about whatever. I don't know. Psychology was a strange one. Some courses were good. What's it called? Rogering. What's this guy? Some therapy concept. Whatever, I'm rambling. Yeah, good luck with the essay. How many years until university? Not so many, right? Thank you. Thanks a lot. Okay, well, that's okay. Try not to get broken inside in the last year of school. retain your spirit, and then you've done it. School tries to break you. Don't get broken. Stay strong. Bye bye. See you soon. And closing scope. What am I doing? A procedure ended. Here we got it. Steps: find an unmapped question X. Find this, map this, okay. Yeah, sure, because it's a while loop. Yes, of course, it's all correct. Because it's a while loop. It went through 2 times. So we have a total of something like 6 steps. The while doesn't count. 1, 2, 3. Find, and map. Yeah, we have 6 steps. And the path is still valid. Because we never invalidate them. Okay, interesting. Here we have something small. There are sub-procedures. Yeah. Init after and steps. I should make these automatically my counting functions, my grammar functions. You give it a number and it makes a little string. Da, da, da. And steps. Boom. Okay. The procedure ended after 6 steps. Zero steps, 3 steps. It will be the same path object, I'm sure. Okay, how about we make the backtracking an explicit command in our language? So we say run funny algorithm with backtracking. Then we don't need this here anymore. This fires too much. All the sub-procedures and everything. How about we make a native predicate here? X with backtracking. It's not going to work. Let's see how flexible this engine is. The X. Yeah, there's a problem. We need to replace this funny algorithm with a procedure, but that's done in a different area of the engine than where we are here. Just little problems in the concept. How do we do this? Oh, this is annoying. Yeah, let's just let's do something simple here. Run with backtracking. Okay. Procedure. Okay, dot path. Philosophy bot 2? Where is that coming from? Oh, it's the name of the module, I guess. Whatever. Path. But okay. Let's see if the path is still valid. It will be because we never invalidated. Path not valid anymore. So now we take the last half, count the steps we have, take the last one. Path is empty. Nothing to backtrack. If the path is not empty, take the last step and backtrack it. Backtracking, last step, results. So now result should not be null. That makes no sense. It's either false or true or variable mapping. Okay, so if it's false, we discard the last step. Let's print a lot here. Discarding last step as it is done. And this is probably a loop here. While licensed to run. Okay. If oh, we forgot something here. We forgot something. We need the rest of the procedure in this step. Or maybe we'll actually change the architecture. Now we're getting into the hardcore stuff. Here it gets boring, I guess, but not for me. Here it gets interesting. If we want to backtrack, we have to execute the rest of the script at that point again. So we need that. Yeah, we need a different architecture. It's pretty tough. It's tougher than I thought. Backtracking is kind of a magic concept, isn't it? Okay, let's transpile this, but it's not going to work that well. Okay, this always returns true. No problem there. Parse procedure. That is trivial. Should do this, so run X with backtracking. Run with backtracking. With backtracking. No. Run with backtracking. That should work. Come on. That has to work. Come on. Come on. Run X backtracking. Am I saving my engine? I have a tendency not to save files. Got fact, run, backtracking. Are you kidding me? Please find the predicate. Now it's making me angry. It's not finding this predicate. That's just crap. Oh, right, yeah. Okay, no. Yeah. A little annoying. It is work in progress. The language is still being defined. What is the procedure? What is the fact? How do we handle those? It's not super complicated, but it has to be defined properly. Okay, now it, yeah. Now there's a parsing problem. It's splitting this into 2 parts. No, it has this first. Got procedure. two filtered paragraphs, start and this. That's okay. Got logic rule, start to procedure. Right. I know what it is. I know. Okay, yeah, it's something we have to solve. We're doing pretty much smart parsing here. We have Python-esque indentation here, which is significant, and we have brackets which have to be kept together. So yeah, I can do that. Python group Python style indents. Yeah, okay, I got it. I think I got it. Here we split it into lines, but if there's an opening bracket that doesn't close on the line, it extends for multiple lines, then this has to be kept together. Do we have something like that? Lines, brackets. Oi, 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 we have it. Honoring brackets. Almost the right thing. Comments now. Okay. Lines. And bracket counter 0. How many open brackets? We keep merging lines until there is all the brackets are closed. E.g. Input this will yield a so keeping whatever. Yeah, this is important. We have to make this. It's a speedrun to AI, but it doesn't mean it's fast. It's just the fastest way to make a new AI that doesn't exist. Okay, we tokenize the line. Some base work here. Let's assume these are all brackets. Bracket level. I have this somewhere, but just gonna make it on the fly. Hello. So now we know the bracket level at the end of the line. If bracket level is 0, we flush what we have. Start line where current block starts. If it's always going to be here. Lines. We dump what we have. And we start over at the next one. And in the end, I believe this. Huh. Another magic function. Another fail. Sure. Let's make a test function for this. That better work. It's our central parsing. It has to work. Let's make a test function. If A and B, blah. It's not indented, just like this. Okie dokie. Stop failing. I didn't add the function. 5609. Where's my assistant? Here. Where is my eval? Okay, that looks really close though. That is really close. Yes. Let's make a new one. Honoring brackets. So this is the really smart Python style indentation detector, which accepts multi-line statements when they have open brackets. Okay. That might work, I think. Start from the top. Got logic rule, procedure, unpythonized. Yeah. It kept it as one long line because the bracket doesn't end until here. That's good. Got procedure, running command, run with backtracking. This is a wrong mapping, it doesn't matter, it just fails. This is a correct mapping. Run with backtracking. Okay. Okay, it has a procedure. Very nice. While there, yeah. Okay. Okay. Ends after 0 steps. Alternative. Run and ran. Ran. Where is my ran? Here. We ran this procedure with backtracking. Yeah. This backtracking thing. It's so complicated. This, yeah. Because this run parse procedure thing, the central runner function, it doesn't do it in one step, which is okay. It posts things to run later. So when this function ends, when this function finds a while statement, for example, here, it doesn't execute it, but it adds it to procedures to run. So we have to check back much later. And do the backtracking then. Backtrack. Yeah, this does not make sense. We need to hook something to the end of this procedure. Which doesn't sound that hard, does it? We can do the prolog operator. Prolog has an operator, this exclamation mark. In Prolog you would have, I mean the syntax in Prolog is different, but in Prolog you have, no, this is not the operator. We can do fail actually. If you put fail there, it says, oh no, I backtrack. No, I mean here. What's this? Oh, this is hard. I just have to change the architecture. We're not only running procedures, we're running procedures and later get the backtracking option. This is hard. I might even stop streaming. I think I'll think about this off stream. Yeah, that's a good idea. See you later.
See you later.